Okay, thanks to the previous speaker who already did quite a lot of my work, so I'm also gonna speak a bit about CEPH, but you will probably, we skip the whole in-depth things about that. So, what I'm gonna speak about today is who am I, a quick overview of the cloud solutions we've looked into over the last half year or something. And more specific, how we plan on using that in Bareos, both as a storage device and also because I just heard again that you cannot back up a CEPH cluster, which I find a bit strange. I already heard that also in other presentations, but we are trying to do something that you get at least back up part of your cloud storage, so that you can just as a normal file system just access it and get backups of it. So, yeah, who am I? Good question. I studied data communications from 89 till 95, so a bit different than the work I've been doing after graduating. I've been maybe some people know, but what you're probably using, at least some of my code every day, or at least it's in your kernel probably. I wrote in, during my study, I wrote the Linux disk quota and the BSD accounting stuff that's in Linux, at least the first version. It's been maintained later on now by someone from SUSE, but I did the first implementation. I've been working for about 15 years as a senior consultant, mostly in the banking sector, and I come from a bit different background than probably most of you. I come from a Solaris background. I first did Linux in my study time, then switched to Solaris, and now are switching back to Linux again after Oracle bought Solaris, or at least Sun, and so Solaris is a bit moving out of the picture. What's my relation to Bacala? I started using and also programming some stuff for Bacala in 2008. I did quite a bit of stuff on it in those years. We forked the code base in 2012 because of all kinds of problems, which I won't go into details. Currently, I'm around the number third independent contributor to Bacala, so it's not that we only did Bareos, but we did at least I did a lot before, and all other people's also. And I'm one of the 5 founders of the Bareos company. So the whole cloud storage backup thing. We were at FOSDEM this year, and we got an enormous amount of questions of can you back up to any cloud storage, S3, Swift, how should that work? To be honest, until February this year, I really never looked really much into this whole cloud storage thing. It was more probably for it seems to be getting a bit more attention now, but up until now, for me at least, it was more or less a buzzword, everything in the cloud, whatever. What we've been looking at the last half a year, and what some stuff is already being implemented, is how can you use cloud storage as a backup device, and even if you probably are not able to back up the complete cloud, still we get questions from customers who have cloud storage. We want to back up at least some important stuff of our cloud storage. Can you do sub backups of particular parts of that? I have no particular favorite cloud storage or whatever. The only thing we look at is from a backup standpoint. We want to have the best performance, and we mostly look at how easily can we implement a storage backend or a backup file daemon plugin using an existing API of that particular cloud storage. What have we looked up until now? We've looked a bit at GlusterFS, at CEPH, a bit at Amazon S3 and Swift. And we also looked a bit at the commercial stuff that's around. Red Hat storage server currently uses GlusterFS. They bought CEPH, so maybe future is that they move to CEPH, or they give you the choice to use either Gluster or CEPH in their enterprise server. But we'll see what happens there. Yeah, I don't know if any of you using Gluster or CEPH or something else. I don't know. Anyone using Gluster? Okay.
We did, but then we moved to CEPH.
Okay. Whatever. Like I said, I don't have a particular favorite. So, for the others, what is Gluster? Gluster is a POSIX-like distributed file system. It has no metadata server. Yeah, it does network-attached storage. It's a bit, it has some analog things like CEPH. It is also, in a lot of ways, it's completely different. It's also a bit strange how they started Gluster. Gluster started as a, that's why as a clustering solution, which they later on added something that it also needs to do storage. So it's a very interesting way how it got instantiated. It has, like I said, it has a lot of things that look a bit like what CEPH is doing. It also has internally it also aggregates quite a number of systems. You can also expand it until, I don't know exactly what the upper limits are and if it's higher than CEPH or whatever, but yeah, thanks. The nice thing about it is that it is fully standard based. It's also running in user space, and CEPH is also. Yeah, the whole things about GlusterFS, and that's what made it interesting for us, to at least be able to do something with it, is that it also has the scalability and so that it can scale to quite a number of petabytes and beyond. It has a proven performance, which we, even in the test we've done until now, that we can easily saturate a network device without any problems. It has a bit like CEPH, also a single global namespace, so you can also, you have one namespace where the whole Gluster stuff is put in. Yeah, like I already said, it runs fully in user space. And it has an additional thing, I don't think CEPH already has that, but what is kind of interesting is that Gluster is also supported not to only use normal network devices, but you can also use InfiniBand connectivity. And yeah, every now and then InfiniBand is faster, then the network is faster, but it gives quite interesting performance capabilities. How can you access your data in Gluster? Gluster has a number of different ways how you can access it. You have the normal GlusterFS native client, which is more or less a Fuser-based file system. You can access it via their own in-user space NFS server. It has an SMB and CEPHs plugin that plugs into Samba. And it also has something like an object store access. Now, how can you use this Gluster stuff today already as backup storage without changing anything? You can already use the Fuser driver, and then you can just create, then you have a POSIX file system additional on your system, which you can just create file storage as you would normally do on any other file system. When we were looking at it, I'm not an enormous fan of the whole Fuser thing, and we were looking for a bit faster data path to bypass the whole Fuser thing. Also, a nice quote I found from Linus is that he also thinks that Fuser is nice, but it's questionable if you really want to use that in production. To show a bit why the whole Fuser stuff is not really that great is this picture I found. This more or less shows how Gluster works with eventually an XFS file system you have there. It goes through the user, then you go from kernel to user space, to the Gluster brick over the network, then to a Gluster FS driver on your in user space on your system itself. Then it goes to the diffuser layer, and then it goes to the kernel VFS layer and comes up again. So you can see that. But if you look at the numbers, then you see that we copy data around 14 times. So that's not really what you think. No, that's really great. Now, there is a better way of accessing Gluster, which saves you quite a bit of copying, because now we're back to only 8 copies, by using what they call is the libcephfs, which is an API library which directly talks to the Gluster, the Gluster cluster, which, so that already saves you a lot of copying data around, and also, in essence, what we've seen is that it seriously performs better than using the fuser layer. The Samba plugin, which I talked about a bit earlier, also uses libcephfs. It is kind of a young API because it's only around 1 year, I think, or something like that. So there are not a lot of programs still using already. What we do see is that things like QEMU also are using now libcephfs. So it seems to be that more and more people are seeing this as the way to access Gluster. Now, then a bit more on CEPH. I'm not completely going in too much detail because I think the previous speaker did quite a good job on telling everything about CEPH, how you can use it for large-scale deployments, how fault-tolerant it is, what it has, all kinds of interesting features. This is the way already talked about by the previous speaker about how you can access it as objects, block, or file storage. This is a picture I also found. This more or less summarizes also the things. So you see here the librados, the Rados gateway, the RDB, and the CEPHFS, which is all stacked on top of Rados. There you already see that the RDB indirectly, there is a driver, I think, for QEMU, KVM over RDB, but I'm almost sure that I also saw that there was one from QEMU that uses, yeah, that's right. Now, how could you then use that storage already? You could use create a file system on top of an RBD device. You could either use CEPHFS, which we already heard is something that we probably should take a bit of time for before we start doing that. We could access it as via the Rados gateway, which means that we have to talk an S3 or Swift protocol, and that's something we currently don't do. Also not sure when we will. For us, the most reasonable thing where we started with is using the librados library to use as a direct access to the object store. Now, this is a bit what I also found, and it's also what the previous speaker said. In the CEPH world, and this sheet is probably going to change soon, but up until now, everything's awesome, but CEPHFS is still really awesome, so it probably needs a bit of time before we really should start using that. How can you now already use that storage in Bareos at the moment? You could just create a file system on top of the RDB device, create it, use it as a normal file storage like you would for any other file storage. You could mount CEPHFS via either Fuser or the native kernel module which CEPH has. But given that CEPHFS is not really fully stable yet, you have to think if you really want to do that. You could try using it as via librados, and there is also another library available with puts it still on CEPHFS, but then via a library. So you don't mount it as a kernel module or as a Fuser module, but you directly access it via a special library. The last two, from our perspective, are the most preferable. Yeah. We also looked a bit at what the other ones are also object storage, but the object storage we see mostly used, the S3, Swift, those kind of things. They are there from multiple vendors. What does get out a bit is that most of the bindings and all APIs you see for these object storage is all for the new style languages. And as we are a bit old-fashioned in the C, C++ kind of world, it's not really that much usable libraries or APIs that you can really use to access these kind of object storage. There's also it's HTTP, HTTPS-based protocol, which means that that it doesn't really fit with the way we currently implement media, because we append to media. So you either have to do a one file one media per job or those kind of thing, because if you put something to such an object store, you have to put the whole object. You cannot put a part of it or whatever. So if we append to something, it will mean that every time you append to it, you will put a new version of your data out. A bit the same as what this morning was said about hierarchical storage. You just run into problems. What you see if you don't want to use the fancy new style languages, most of the implementation, if you really want to do it in C or C++, you get something that's built on top of a libcurl, and then they did all kinds of additional stuff themselves. I think Amanda has a S3 driver, which is mostly based on libcurl. I've looked a bit at it, but yeah, it's a bit too much that to implement ourselves. So we've been looking a bit at what is available in that sense. We found something that at least is a good starting point. It's not really fully great for what we want, but we found a library called libdroplet of Scality. Scality is also one of the vendors which does an object storage. And because they probably have a lot of customers migrating from other storages like S3 or whatever, they've written a library and a couple of migration tools from which you can use to migrate from one object storage to another. So in that sense, they have quite a nice, and it is not fully, they don't support all providers, but at least they do have some implementations for the important providers, so that you can with that one library we can access multiple object storage vendors. Yeah, what's also nice is that it's at least a native C, C++ API. It has something like POSIX storage, which is more or less the way we currently access all our data. We open a file, write to it multiple times and then close it, or open it, read from it and then close it, which is exactly the POSIX model. Given that the object storage has some problems, or at least is not really a POSIX-friendly environment, we still have some problems with really using that. What's also missing a bit is in the library is that it currently, and I don't know if it's on the roadmap or not, it's missing a bit of caching. So that means that if you write something to it, then it automatically tries to push it to S3 or to the other object storage, which would be nicer if you just write a big piece of backup to your media, and then that it caches it eventually, and when you're done, or at least if it's has enough, then it starts uploading all the stuff. So how can you use things like object storage or S3 currently? With Bareos or any other backup product. There are, to be honest, only two, or maybe three real things that currently work a bit. There is an S3FS written in C++, and there is one in Python. Then again, it mounts it again via fuser, so would not be my favorite, but yeah, it's better than nothing. So for now, that's the way you could use it. There is also something called S3 Backer, which is a bit more interesting because it has all kinds of caching, but the only downside of it is that it can only do it for one file. So yeah, you could lay it out as so that you create a multiple of those instances for each media, but it really doesn't scale that well, that great. Yeah, also something at least to think about when you're using S3 is that it could give you quite a bit of costs because you have all kinds of upload and download costs, and especially because most of these things can only do don't really do append. So every time upload the whole data, it could run into you could run into quite a number of costs. Okay, now that was a bit the first things about what cloud storage is available, what did we look at. This is a bit more of how could we use the whole cloud storage in Bareos. Like I said already, we are looking at two angles here. We want to use it as a backing store, so as a media, so that the storage daemon can save data to the cloud. You could already do that, of course, today with just the file system abstraction available with all those cloud solutions. But we want to take a bit, want to take it a step further so that it works and is somewhat more integrated. We also looking a bit because we also got some customers asking about that, that they have a CEPH or a Gluster environment and want at least to be able to partly back up that environment. So we're also looking at a way of doing that from the file daemon, so that the file daemon can connect to your cloud storage and can do a backup of either a subset or you could of course already do that today, especially if you have a normal file system abstraction, because then it is just a file system on the file or your server, and you can just backup it today. But it doesn't really use. There are, and I will go into details a bit later. There are some interesting features available in some cloud storage with snapshotting and all that kind of stuff, which is kind of interesting when you're doing backups, because then you could at least make sure that that if you do a backup, that you at least that things don't change while doing the backup. If we want to use cloud storage as a backing store for our data, what we're looking for is a close integration with the storage daemon. So we want to get at least to a point that we have the shortest path from the daemon to the storage, so that you don't have a thing like I already showed earlier with Gluster, that you don't have the enormous copy of data all around. For now, we concentrating because we don't want to change the media format yet. We are looking at maybe doing some things there, but at this point in time, we were not ready to really change that. So we want to use at least something that has a POSIX interface, so that we can just normally open, write, and close the files we put on the cloud storage. Also, one of the design goals for at least, and this is what we call phase one of this stuff, is that we don't the format saved on the cloud is just exactly the same file format used on a normal file system. So nothing special there yet. We may look in the future and change things to make things a bit more clever and do some other tricks, depending a bit on what nice tricks we can do with that particular storage. Yeah, the direction we are thinking about, and so you will see later on that some is already implemented, is that we want to extend, want to have multiple storage backends in the storage daemon. Well, even today there are already, of course, there are a couple. You can already use tape storage, you can use file storage, you can use a FIFO, and there were a couple more. We removed a couple, but so for that we want to have something like an abstraction layer of the different type of devices. What we had before in Bareos, and we changed that a bit, is that what you had one kind of device, and the device driver inside the storage daemon just checked every now and then from, oh, am I a file? Oh no, am I a tape? Yeah, then I have to do, oh yeah, then I probably have to rewind something. Or so that was not really ideal, so that's something we wanted to address. What's also interesting, we want to make the packaging a bit, we also have to think how we're going to package all this. And if you package it directly within the storage daemon, that would mean that we get an enormous amount of dependencies. So because we could have a storage daemon that can do both Gluster and CEPH, and that would mean that you have dependencies on both of those environments, which would mean that we get an enormous dependency hell in our packaging. So what we've done is that we try to do a bit more of a device layer abstraction, which means that we now use internally a device abstraction that means we have a device, and that which is because we are C++, we just use inheritance of the class structure, and we if we want to implement specific devices, we just use the default device, which is normally a file device, but a tape device, which does all kinds of additional stuff, just overrides the normal things a file device does. And that's the same we're going to implement for the other device classes. Yeah, what's available in 14.2.1, which was officially released yesterday as a beta. We have a file backend, which is always compiled in, so you cannot really remove it. We have a tape backend in separate packages, so if you don't use tape anymore, don't install the tape packages, and you don't have all the dependencies anymore. That means like that you don't need to install MTX and all that kind of stuff. We have a FIFO backend, which I'm not sure if anyone uses, but so it's also questionable if it really works. But and what we did until now, and that's already also available, is that we have a GFAPI backend, so we can back up to Gluster, we can back up to Rados via librados right away. We can back up to CEPHfs, and we have an object storage backend, but as that is built on top of Droplet, and Droplet has some problems with POSIX compatibility. That's not really a working solution yet. Yeah, what is kind of nice is if you save something to a CEPH or Gluster volume, or yeah, CEPH or Gluster, all your files that you create there, all your volumes, are exactly in the same format, and which means that you can use normal tools to get things off. So you could just get with Rados get, you can get a Rados object from the CEPH environment. If you just copy that file onto a disk and then say that it's a file storage, then you can use it. So it's nothing special. So exactly the same data is stored either in your cluster, or but it gives you at least the ability to also use it in outside of your storage cluster. Instead of doing copy jobs, you could do some other interesting stuff. Both CEPH and Gluster have their normal way of doing internally replication, like if it wants to be mirrored or all that kind of stuff. At least Gluster, I think, and I think in the previous presentation says that CEPH is not that far yet. But Gluster has something what they call geo-replication, and with that you can do replication over multiple sites. And as we just see everything as a standard device, it could mean that you could just access those geo-replicated information in another data center and just restore from it. What we don't do yet, but what I am planning to add, is that you in the future allow read-only devices. So that you mean that you can just replicate it to another storage cluster and just access it remotely with as a read-only device. What's the future of our cloud backends, which we probably going to work on the next months, years, whatever. We are at least trying to work out a working solution for the whole object storage. We probably need to do, for the time being, some chunking method, so where we chunk the media into smaller pieces so that we don't have the problem of appending to a file all the time, but that we can only upload particular chunks to this object storage. And at least what we also want to do is a bit of local caching. I'm not quite sure how we're going to do that. Maybe we're going to try integrating that with a bit smarter spooling technique or something like that. Yeah, also something at least I've been looking a bit at is, and I don't know if there are any people using Windows Azure here, but it seems that they have a way of storing blobs in their object storage, which matches a bit better with our POSIX way of writing things. And there is a library that seems to fit a bit, that we can at least also write to those kind of things. It probably will mean until we get a real request from a customer, it's not likely that we will start on that, but who knows. So that's mostly how you can backup to use the cloud as a storage backend. But we want to go a bit further. We also want to be able to backup parts of your cloud storage. Like I said, because of dependencies, we are going to implement it as plugins. So it means that we get additional file daemon plugins written in the native language, so not in Python, but in C, which integrate with more or less the same libraries we already saw for which we also use for using it as a backing store. We do have some problems we have to solve there because the original plugin interface that came from Bakula is not really fully suited for writing plugins that more or less mimic what the file daemon normally does, so scanning files, or checking, all that kind of stuff. It has completely no support for things like hard links, and so there's a bit of work there to be done. The whole idea is that eventually we want to get it as a normal, so the whole cloud backup as a normal backup and restore functionality in the file daemon using those plugins. And we're probably going to reuse, we've done for the storage daemon backend, we did a bit of configure logic, so that detects if you have the CEPH libraries, if you have Gluster installed, if you have something else installed. So most people probably don't compile themselves, but if you do, then if you install the right libraries, then it will automatically find out that you have them and will compile the right things. What challenges do we have in the file daemon before we even get this up and running? We have some problems that there is no really, like I already said, there is no handling of hard links. Now, for some environments, that's not really a problem. If you look at CEPH and you access it via Rados, then you probably only see simple objects which don't have a hard link. But if you look at things like Gluster, which is more or less a normal file system, you can see any file on it. It could be a hard link file, it could be a socket, it could be everything. So that's, and there are no real good examples to do that yet. So another interesting, and also ACLs are not really that much of a problem yet, because I've not seen any cloud storage that uses ACLs. So, but what we do see is that, for instance, CEPH is using a lot of extended attribute stuff. And currently, the plugin interface doesn't have any support for any ACL or X-attribute backup as part of the plugin interface. The file daemon can do that. I wrote almost most of it, at least the whole extended attribute stuff. But there is, in the plugin interface, not really a way to be able to save and restore those information. And especially, I think, for things like CEPH, it is kind of important that we can back up that stuff. We've already done a bit on that. It's not really in the release code, but it is in the master branch. I did a bit of refactoring of the whole hardlink code. So that means that that at least the file daemon now can also understands hardlink files if they come from a file daemon plugin. To do that, I dropped a bit of duplicate code, which was a bit strange. What I found out in the file daemon is that there is a completely duplicate hash table implementation, which is kind of strange. And so what I've done, at least it's in master already, is that I reused our generic hash table code to also use that for hardlink files. For the HCL and extended attributes saving, I've started coding a bit. It is partly working. It probably needs, I hope that it will soon go for review and that we can probably merge it into the master tree. Depending on how stable it is, it's quite possible that we also backport it to a newer 14.2 version. We're not really decided on that. And probably interesting also for the Python plugin programmers is that we also plan on extending the that interface to also be able to use this new ACL and attribute saving. What have we done until now? The initial coding of the FD plugin using librados is done. It uses some nifty things. With librados, you can point to a certain pool. You can use multiple pools in your Rados environment. And then it uses a numerator, what it's called in the Rados terms, and with that you just get more or less all objects which are available in that store, and on that we can do filtering and all that kind of stuff. We do one additional thing. Before we start reading anything from the Rados pool, we snapshot it and then say to the plugin, use this snapshot during the whole backup. So that means that if something changes during that stage, that you don't get any objects that are changing during backup. There's no synchronization yet between Rados and the backup software, so still you could be taken a somewhat moved picture of things. And like I said, it's in early stage of testing. At least it doesn't crash. So. What we've done for Gluster is more or less the same, but because it's a bit different API, we need to write a new plugin, which is for the first phase we will only do regular files. Later on we probably do at least try to do all kind of files. It looks possible. It's just a lot of work, and that's why I haven't done it. Currently, it scans the whole file system you give it. So if you and in Gluster terms, you can also split file systems. So you could also do backups of only parts of your cloud storage. But it more or less does exactly the same what a normal file daemon does. It scans through all objects on the file system. Uses also the normal timestamp comparison or accurate data if available. What is interesting, but it's not really ready in Gluster yet, is that for the replication they use something like a changelog, and eventually, if that API stabilizes, it would be an interesting idea to see if we can use that changelog for our differential and incremental backups. Although probably not a lot of people are going to use CEPHfs, but we already did most of the coding for CEPHfs, and I see that I copied a bit too much, but it is, no, that's not true. Why do we already have this? Now, it's quite simple, because the POSIX API CEPHfs exports is almost analog to how Gluster does it. So it was mostly search and replace, a couple of calls, and that's about it. So in that sense, also, it does more or less the same. It scans the file system, and uses accurate data in a normal way. Yeah, so what about the future of these Cloud FD plugins? Yeah, we're probably going to merge them into master after we've done a bit more testing. Not got further than some initial testing with it, so I really want to see it a bit more broadly tested. We probably put it into a beta program and see if some people are willing to try it out, because we probably will take a bit of time before we really call it stable, and because otherwise we get, oh yeah, I made a backup and it doesn't work, and so we really need to get a bit better feeling if this is something that people want. We at least know one customer that's interested in it. Yeah, to really finalize things, we probably need to get a bit more sponsoring on this. So it also depends a bit on if people think it's usable, want to use it somewhere. Yeah, and when we probably work out the whole stuff with how we can use the object storage as a backend, and by chunking and all that kind of stuff, and maybe by using the libdroplet library, we would maybe even allow you to back up object storage. Now, for S3, it probably doesn't make much sense to try to back up the whole S3 cloud storage, but if you have some internal storage which uses an S3 protocol, and you really want to back it up via that protocol, maybe that's something you want to try. Any questions? Yeah.
You told us about saving, backing up the librados space.
Yeah.
How do you do the librados restore? So if the librados crash and restoring the data.
Just as a normal backup. You just select your objects you want to restore, and then it will push them into the librados object back.
Okay. Or you create.
Yeah. Well, if you crash your complete librados, you first have to create an empty pool or an empty librados environment. So, or your replication breaks, or if it becomes corrupt or whatever, you create a new one, and it is as a normal backup. So you just restore your objects you want to restore, and then it will just create new librados objects with the data in there. So from a user perspective or an administrator perspective, you don't even know that it is something different. Then it is just another type of file system.
Full information to restore it.
Yeah.
The storage support for Gluster and CEPH, how much stable is that?
Like I said, it is as a technology preview. You probably know that name from Red Hat. So we don't know when we take that off. But what we've seen, at least for Gluster, we've seen that it performs quite well. We need to do a bit more testing with what block sizes do you need, all that kind of stuff. Because you need to do a bit of tuning. Because normally the default block size of Bareos and Bareos was also always 64K. That probably doesn't work too well, even though, because, yeah. So in that way, but of what we've seen until now, it looks quite reasonable, stable. But we probably will do a bit more testing over the next months.
Maybe as like for A7, we added the package for Gluster backup to the vulnerability
Yeah.
to install Bareos. That's the package it will install, and it's working.
Yeah, I mean, I was just wondering if I want to use that in production or not. Or, I mean, when?
When in production, then I would wait a couple of months. Like Jörg already said, we are also looking a bit in the packaging how we're going to do that, because Gluster is now available as in the default repositories of Red Hat 7, so also CentOS. But CEPH, you always have to go to ceph.com, so we're not quite sure on which platforms we're going to provide pre-compiled stuff. But essentially, you could also compile it yourself. So it's not really a problem. You could even just, if you use the same version as today, you could only compile the backend driver, because that's just a shared object. And you can still use all the packaging stuff. No, I don't. Yeah.
One question would be, do you have an environment where you would like to back up to? Because, yeah, for me? Yeah. No, I'm just wondering, because we are using Gluster and CEPH as a backend storage solution now, but with a fuzzy layer, like a positive system. So it would be very good for us if you would like
Yeah.
to, because if you have a running environment, then it might be very interesting for us to see if there are problems. Because our own test environments,
Yeah, but then still you could have multiple devices in your storage daemon, so you can still write to write a fuse away also, and maybe do some less qualified data to.
not crash your running environment. The rest would be of our software crashes, or the
Yeah.
worst case, if you get your data back,
Yeah.
see if I'm quite sure that your cluster will not crash. Yeah, I think also.
Yeah, because we're using normal API, so if it crashes, then it's a bug introduced by Gluster itself, so they have to fix it. No. I'm just using a normal API call, so if I can crash it that way, then it's interesting.
Actually, the libcephfs package comes from Red Hat, so
Yeah. Yeah, we're testing it internally, and we can saturate the gigabit link, but that's just because our test setup is not bigger. So we probably would have, with CEPH, we've done a bit less testing, but we so. But.
There are no special recommendations for the file system to put on the RDB copy device.
Yeah, I would not do it. We on purpose try to do doing this with a native API of stuff, because you could do that, but if you just make a picture of that, you already see that you put all kinds of additional layers on top of that. And we're now, at least with CEPH, if you put it into Rados right away, you're using the fastest path into your cloud storage. So anything else is more or less doing the same with an additional overhead. Yeah, and I don't think, like I said, we already said earlier, the blocks are checksummed. So if it really screws up, then at least it will tell you that it's corrupt.
Thank you a lot.
Okay.